This conference will now be recorded.
Hello, everybody. Jordan Gerth here from the National Weather Service Office of Observations. Thank you for joining us for the Satellite Book Club Seminar Series. This is session number 110. Title of today's presentation, Hermleigh, Texas EF2 Case, a Study in Mesoanalysis. Our presenter, Brian Curran, Science and Operations Officer in the Weather Service Forecast Office in Midland, Texas. Our discussion after the presentation will be facilitated by Carl Jones, meteorologist with the Forecast Office in Grand Forks, North Dakota. So thanks to both of them for being with us today. And thanks to all of you for being here. Hope your summer is going well. Just a few reminders before we get started. As you just heard, the session is being recorded. There'll be an opportunity for Q&A after the presentation. If you have a question, we ask that you post that question in the chat and we will field it through there. If you have a longer question or like to engage in discussion, just please note that. And if you haven't signed in with your name, maybe you signed in with an office account, please note your name in the chat. That way we can get back in touch with you and properly introduce you. We're also looking for future presenters. Please feel free to get in touch with the TowerS team if you'd like to be part of this great series. And we have an opening for September 15th. So we like to keep this going week after week. If you have something that may be topical as we head into the fall months, doesn't have to be exclusively related to satellite, might be a presentation that you're going to be giving at National Weather Association meeting next week or something else. Please get in touch with us. We'd love to give you a platform to share your case or your information, your application with the field. And if you're looking for training materials that you may be unaware of or unavailable, Brian Mott at the Office of the Chief Learning Officer can help with that. I'd like to thank our TowerS team, Kashad Bowman, Lee Byerly, the Office of the Chief Learning Officer, GOES JPSS program, for all of their support of the book club, and of course our presenter and facilitator today. So our presenter, as I mentioned, Brian Curran, started working for the federal government at the National Severe Storms Lab as a part-time student meteorologist aide in 1982, eventually becoming a field support meteorologist at NISL in 1988. In 1990, he transitioned over to the Weather Service as an intern at the Forecast Office in Norman and pulled a brief stint at NWS headquarters in the Techniques Development Lab between 92 and 94. Then went back to the field as a journey forecaster at WFO Fort Worth and moved to Midland, Texas as a lead forecaster in 1998. Promoted on station to a science and operations officer in 2007. Brian hopes to remain at Midland until 2030 with 45 impressive years of service at retirement. So Brian, we're glad to have you back at the Satellite Book Club, looking for your presentation today.
Thank you, Jordan, for the introduction. I appreciate it. I'd like to welcome everyone to this week's SBC Talk. Again, my name is Brian Curran, and today we'll be discussing mesoanalysis topics prior to an EF2 tornado that struck Hermleigh, Texas on the evening of May 1st, 2022. Next slide, please. This is the SBC 20Z outlook. You can see that much of West Texas and the Permian Basin are in enhanced risk. Not shown are the relative high 5% tornado probabilities and the significant 30% hail probabilities. This 20Z day one outlook specifically mentioned hail 2 to 4 inches in diameter, which we did observe. Next slide, please. Here is the preliminary damage survey report for the Hermleigh, Texas tornado in Scurry County, Texas. Struck at about 7:45 p.m. CDT on the 1st. It had an estimated winds of 115 miles an hour, path length of only 0.3 miles, fortunately, with a width of 150 yards. Lead time from warning issuance to damage was approximately 10 minutes, and fortunately, again, there were no casualties with this tornado. Next slide, please. The tornado path here is noted in the upper left of the image with damage indicators noted along the path. US Highway 84 is indicated in orange and is labeled at the bottom. Next slide, please. Here's the pre-convective environment as seen by GOES 16-day water cloud phase RGB. The white circle notes the approximate location of Hermleigh, Texas. Now note the billow clouds to the east and north of the white circle initially indicative of a stable boundary layer. This transitions to horizontal convective rolls further south and west, then to open cell cumuli. The upshot here is that there's a boundary draped across the northeastern Permian Basin, and we'll see this boundary evolve in subsequent slides. Next slide, please. So here we're going to talk about mean layer CAPE and ML-SYN with the GOES 16 Viz IR sandwich imageries at 21, 23, and 01Z. Next slide, please. Now here's a Viz IR sandwich at 21Z on May 1st. The white circle here indicates the approximate location of Hermleigh. Initial convection is noted along the dry line over Lee County, New Mexico. Billow clouds are observed through the thin cirrus north of Hermleigh, indicative of stable air mass, but there are some HCRs, horizontal convective rolls, noted southeast of the area. Nothing's developed over the northern Permian Basin yet. Next slide, please. So we have the ML CAPE, which is the lowest 100 millibars, and ML-SYN valid at 21Z on the 1st of May. Surface winds here are plotted by convention. The black circle on these slides, the subsequent slides, will indicate the approximate location of Hermleigh, Texas. Now the air mass is mostly uncapped with around 1,500 joules per kilogram of ML CAPE available around Hermleigh. A residual boundary is noted extending north of Hermleigh and curling southeastward to east of town. But is there a second boundary southwest of town? We'll see. Next slide, please. Okay, so here at 23Z, we have a vastly changed convective situation. A fist of God, otherwise known as a massive penetrating top from a cumulonimbus cloud, is developing over Borden County, Texas, west of Hermleigh. Right in the zone where the second boundary was noted in the ML CAPE field. Note the cold, which would be less than 65 degrees, minus 65 degrees C, cloud tops associated with this storm. Next slide, please. At 23Z on May 1st, ML CAPE is increased to 1,500 to 2,000 joules per kilogram. Note the tightened gradient of ML CAPE west of Hermleigh. Also note the backed winds in the vicinity of the black circle. We'll get to that here in a moment too, please. Next slide. So at 01Z, we have a couple of things to look at. The fist of God, or the penetrating top, is over Hermleigh just after tornadogenesis. An above anvil cirrus plume is also evident within the cyan oval, which is almost always a harbinger of severe weather at the surface. At this time, I was working the Mesoanalysis desk, and I measured minus 78 degrees C tops, cloud tops at this time. Next slide, please. Now at 01Z, there's something funky going on with the surface wind field in the vicinity of Hermleigh. The surface winds appear to be back significantly. Well, what does that mean? Could the RUC model be picking up on the near storm environment? We'll see. Next slide, please. So let's look briefly at surface theta E and advection. Next slide, please. Now here's the equivalent potential temperature in green and surface winds at 21Z on the 1st. Theta E advection is in purple and in units of degrees C per hour. Now you see the dry line is noted by the brown dashed dot line, while the warm fronts are noted by the solid red lines. And I apologize, as Google does not support meteorological symbols just yet. A warm frontal boundary is indicated in the equivalent potential temperature fields extending from the Texas Panhandle south and east across North Texas. However, there appears to me to be a secondary boundary just southwest of Hermleigh, where an area positive advection is noted. Next slide, please. At 23Z, we note that there's a secondary warm frontal boundary that's lifted north of town. But is there a third boundary south of town? We'll see. Next slide, please. And at 01Z, this is as before, the main boundary is tightened up north of town. You see the dry line is really tightened up across eastern New Mexico down into the Big Bend of West Texas. But in terms of Hermleigh, there appears to be a weak gradient of equivalent potential temperature just north of town. Next slide, please. Now we're going to look at some surface deformation axes of dilatation, and I won't read the slide, you can read it too. But what I want to note is that when the axis of dilatation is aligned with the contours of deformation, frontogenesis is likely. The larger the length of the axis of dilatation, the larger the magnitude of the resultant deformation. Next slide, please. I like using this product as it relates to frontogenesis. Note the longish northwest-southeast trending axes of dilatation west of Hermleigh at 21Z. Potential temperature here is plotted in red. Note that the axes of dilatation suggest some stretching. Next slide, please. At 23Z, something is happening south and west of town. The axes of dilatation are roughly orthogonal to the gradient in potential temperature, indicating that frontogenesis is occurring. The field axes are the total deformation. You can safely ignore the strong values well west and southwest of Hermleigh. That's just a dry line cranking up for the inevitable Pecos County ice machine. Next slide, please. At 01Z, note the maximum total deformation, which is on the order of 10 to the minus 4 per second, just west of Hermleigh at 1Z. The axes of dilatation remain orthogonal to the potential temperature gradient. Also note that this is where baroclinic vorticity is created and stretched, which brings us to the next slide. Vorticity equation. The solenoidal and divergence terms are where the magic happens. We want to see vorticity convergence so that the divergence term becomes positive. We can ignore the tilting term for now. This will become important for mesocyclonic sustenance. The solenoidal term becomes positive in areas of frontogenesis. So the next slide, please. Here's some more math, but what I want to show in the red box is that the result reveals that the vertical vorticity increases exponentially in time when subjected to a stretching flow. It's important to note that horizontal vorticity from baroclinity and weird and shear, when stretched in a deformative flow, increases via conservation of angular momentum. Recall that Earth's vorticity is on the order of 10 to the minus 4 per second. In frontogenic zones where strong deformation occurs, this value can increase by 2 orders of magnitude. Should a storm latch onto this boundary where the vertical shear is clockwise, it will ingest helically rich air and via tilting promote mesocyclogenesis within the storm. Let's look a little further into the weeds. Next slide, please. So let's look at surface vorticity and divergence. At 21Z, there's a small area of enhanced surface vorticity and convergence, which is the negative numbers here, noted south of Hermleigh. Recall that there was a boundary in the general area at the time. We're locally increasing the time rate of change in total vorticity. Next slide, please. At 23Z, wow, we see strong convergence of vorticity near town. Also remember at this time there was relatively strong deformation of the surface flow, indicative of increasing frontogenesis along the boundary, making the solenoidal term positive. We're increasing that vorticity along the boundary. Next slide, please. Now we have the surface vorticity and divergence at 1Z. The ruck is picking up on convection-associated cold pools, which are areas of divergence shown in blue, but there remains strong vorticity convergence in the vicinity of Hermleigh. Next slide, please. So let's look at 0 to 1 kilometer SRH, storm relative velocity, hodographs, and predicted storm vectors. Next slide, please. At 21Z, here we have the 0 to 1 kilometer SRH in joules per kilogram, and it's left to the student to show that joules per kilogram are equivalent to meters squared per second squared. And the predicted storm motion. There's not much to get excited about at 21Z here, only around 50 joules per kilogram of 0 to 1 kilometer SRH. Next slide, please. Now, this is the RAPS, not the RUC, but this is the RAP 21Z hodograph and CAPE analysis. Now, there's some directional shear with height, but it's confined to the lowest 1 kilometer or so of the atmosphere. Also note that there's a local maximum of CAPE south-southwest of Hermleigh. Next slide, please. Now, at 23Z, things are getting a little spicy southwest of Hermleigh in the vicinity of the dry line, but we're still looking at around 50 joules per kilogram of 0 to 1 kilometer SRH, maybe not enough to support tornadogenesis yet. Next slide, please. Here's the RAP hodograph and CAPE analysis, RAP hodograph and CAPE analysis at 23Z. The maximum CAPE is migrated closer to Hermleigh, and we see signs of increased vertical shear in the lower levels west of Hermleigh. Next slide, please. At 01Z, holy moly, what happened? We observed 0 to 1 kilometer SRH near Hermleigh around 150 to 200 joules per kilogram, more than sufficient to support strong mesocyclogenesis. The values are even more insane for the Pecos County ice machine well southwest of town. Note that values around 2,000 joules per kilogram, or meters squared per second squared if you prefer, are around the 75th percentile for significant tornadoes per the Thompson et al. 2003 study of rock proximity soundings. Next slide, please. This image is courtesy of Cameron Nixon. Here's a plot of hodographs and CAPE valid at 01Z on the 2nd of May, which would be 8 p.m. CDT. This is roughly 15 minutes after the tornado time. The gray arrows here indicate the storm motion. Note the large looping hodographs turning clockwise with height around Hermleigh, a classic sign of a helically rich environment. While the area around Hermleigh is in a relative minimum of CAPE, there is still sufficient CAPE, around 12,000 joules per kilogram, for storm fuel. Next slide, please. So let's look a little closer at the hodograph analysis at 01Z. Now in photography, there's a golden hour, which is an hour around sunrise and sunset when the light is soft and the colors will pop. Next slide, please. In supercells, the golden hour is the time around sunset when the planetary boundary layer, or PBL, decouples. The low-level jet kicks in as winds above the PBL become supergeostrophic. If a supercell storm is present and there's just enough forcing due to buoyancy and convergence along that forward flank updraft downdraft interface to mitigate the minimal ML sin due to decoupling, the ML CAPE will be liberated to feed the storms. This forcing is increased, the supercell storm is riding a boundary where baroclinic vorticity is stretched due to deformation on the order of 10 to the -2 per second and then tilted into the vertical. Next slide, please. So here's a HER SKU-T Lon P sounding and hodograph at KMAF, Midland, Texas, valid at 01Z on 5/2/22, plotted by convention. Now, if we assume this to be representative of the near storm environment for the Hermleigh, Texas supercell, then the thermodynamic and kinematic parameter space suggests that storms will rotate. The fairly low LCL, especially just on the cool side of the boundary, would tend to support a potentially warm RFD, further supporting tornadogenesis. In fact, the effective layer STP seen at lower right on this image indicates a probability space near the median for an EF1 tornado and is close to the median for EF2 tornadoes, which of course was observed. Next slide, please. Again, this is an image courtesy of Cameron Nixon. This is a RAP hodograph at Hermleigh that's been translated to be in the same reference frame as a storm. The black arrow indicates the storm motion. Note the large area, which is highlighted in gray, swept out by the 0 to 0.5 kilometer shear. This is likely due to the wrap indicating strong inflow into the storm, along with the low-level jet becoming super geostrophic as the PBL decouples. Next slide, please. Now recall that the shear vector indicated by zeta S is proportional to and 90 degrees to the left of the shear vector. Now, plotted are approximations of zeta S in the 0 to 250 meter layer, the 250 to 500 meter layer, and the 500 to 1000 meter layer. The storm motion is indicated by the black arrow at the center of the hodograph. At that golden hour at 01Z on the 2nd, the storm is ingesting a significant amount of streamwise vorticity. Next slide, please. So here are some lessons learned. As a mesoanalyst, you need to pay attention to boundaries no matter how subtle. Satellite imagery can't help you focus on these boundaries in your hand analysis. That's a hint for people who don't do hand analysis. Surface deformation, axes, and dilatation can indicate where surface vorticity is being created via the solenoidal term and stretched into the horizontal. So it's good to look at those SBC mesoanalyst graphics. Storms dwelling on these boundaries will ingest enhanced vorticity, which is further tilted into the vertical and stretched via negative pressure perturbation aloft, otherwise known as buoyancy rather. Just like there's a golden hour in photography, there's a golden hour in supercell tornadogenic potential, where the PBL decouples, the flow above the PBL becomes super geostrophic, and the result is an increase in effective SRH before ML sin overcomes ML cape. Next slide, please. So we want to see some eye candy here, and the guys from Rush all agree here too. So let's continue to the next slide here. This is a GOES 16 dirty IR loop with a 3-minute time step beginning at 2230Z on the 1st and ending at 0030Z on the 2nd. The wide inverted triangle is the approximate location of the Hermleigh, Texas tornado. The specks of blue surrounded by white indicated cloud tops colder than minus 75 degrees C. At this time, I measured minus 78 degrees C at time of tornadogenesis. Next slide, please. Here's a gamma adjusted vis IR sandwich with CG flashes. Now, this is just prior to tornadogenesis. You can see the above anvil cirrus plume pretty clearly and the gravity waves emanating from the penetrating top of the supercell. You can also see the above anvil cirrus plumes emanating from the Pecos County ice machine there at the lower right of the image. And those are almost always harbingers of severe weather. Next slide, please. Here we have a GOES 16 clean IR channel loop as before, but with the GLM flash extent density overlaid. The black triangle and start time of the loop are in the slide above. The lightning jump is in progress, as noted by an increase in density of flashes detected by satellite. Note how we see a relative maximum flash extent density coincident with the coldest tops. Recall that the GLM FED quantifies the total optical lightning flashes both in cloud and cloud to ground, occurring with a given 4 by 4 kilometer grid cell over a predefined time interval, typically 5 minutes, updating every minute. You can also see the FED extending down shear from the convective zone, indicating the potential for ground flashes from the anvil, and thus as product, the FED can be used for IDSS purposes. Something to consider. Next slide, please. Here's a closer look at the GOES 16 IR image with the minimum flash area from GLM overlaid. Remember to correct for parallax. The most electrically active portion of the storm is over Scurry County near Snyder. Smaller flashes indicated by the yellow colors are occurring in a newly developed or isolated, embedded, or strengthening convection. Mainly small flashes can suggest growing severe weather potential. Blue and purple minimum flash area reveals larger flashes occurring in the anvil stratiform regions of mature storms and the cores of decaying storms. Next slide, please. So this picture was taken by Nathan Hines. There's a ragged lowering on the rain-free base looking east-northeast. I'd chase that. Next slide, please. Judging from the storm structure and the time of day and shadowing, I'm assuming that this photo was shot looking toward the northwest and the visual manifestation of the mesocyclone prior to tornadogenesis. Now, this is a hint for chasers for eastward moving supercells. This is the preferred position to be in tornadoes near sunset, not in the bear's cage or trying to 0 meter the thing. Note the structure of the wall cloud, the rain-free base, and the vault where large hail is likely falling. We didn't get reports of 2 to 4 inch diameter hail with this storm. You see the scud tags beneath the wall cloud? Could this be rising? Could this be indicative of the potential for a tornado to develop? Something to maybe discuss in your Skywarn class. Next slide, please. So here's a volumetric view from GR2 Analyst, a storm relative velocity using a storm vector of 290 at 13 knots of the Hermleigh storm at about the time of tornadogenesis. Now you're looking east at the storm and from above, with flow toward the radar off to the right of the image. They're indicated by the little radar with KMAF on it, appearing green, and flow away from the radar appearing red. Height above radar level is shown by the white horizontal lines behind and to the right. We're seeing radar returns up to 50,000 feet. The green inbound velocities against the red outbound velocities down low indicate the low-level mesocyclone and possibly an RFD surge wrapping around the low-level mesocyclone. The flow is cyclonically convergent, and at this range of the radar, this is a good signal that the tornadogenesis is ongoing. Next slide, please. This is a Lagrangian frame loop that you can do in GR2 Analyst version 3 of the Hermleigh supercell as seen from the KMAF WSR88D. The loop begins about an hour prior to tornadogenesis and ends with when the tornado developed. The elevation is set to 0.8 degrees to eliminate much of the purple haze due to PRF changes during the period of interest. That's just something that just happens that you have to deal with. Reflectivity is in the upper left quadrant. Storm relative velocity using a vector of 290 at 13 is in the upper right quadrant, with the redder and greener colors indicative of outbound or inbound velocities. Correlation coefficient is in the lower left quadrant and ZDR is in the lower right quadrant. There appears to be a rapid reflectivity increase south of the parent storm and subsequent merger. This may have helped with tornadogenesis. It's hard to discern a TDS at this range, but the relatively low numbers along with a low ZDR and high dBZ indicates to me that large hail is falling out of the storm. At this range, about 100 nautical miles from the radar, it's hard to discern the presence of a ZDR arc, which is indicative of precipitation size sorting along the forward flank updraft, downdraft interface. KDP was not evaluated. So that's pretty much all I have. Next slide, please. Should you have any questions or comments, feel free to reach out to me at brian.curran@noaa.gov. Thanks for watching so far and have a nice day. And I'm open to any questions that anyone has.
Okay, thank you, Brian, for that interesting and educational presentation. I know I kind of was taken back when I saw the equations get tossed our way, but luckily it was a brief instance. So
I was afraid
that.
it was going to trigger some people. So
Yeah, I felt slightly triggered. Yes.
Hey,
So
Brian?
yeah, go ahead. We have someone on the line.
Yeah, Steve Goodman. I'm a bit perplexed. This very tall supercell, you saw very nice flash extent density from GLM and even a trend, and yet oftentimes we find the light attenuated. Was there something different about the structure of this storm that showed up so well?
Steve, I really don't know. It was a very tall storm that was isolated. There wasn't much interfering cirrus in the way, and the penetrating top was quite evident. So that's, could be reasons why we saw the FED and the MFA show up as well.
Yeah, this would be a good case to compare with some of our others. Thanks. Very nice.
Thank you, Steve.
All right. Thank you, Steve, for starting off the conversation. And before we get to other questions, I'd like to encourage the other attendees to stay on for the duration of the discussion. And we'd like to see participation from the field forecast offices and regional headquarter offices as well. And if you happen to ask a question within chat, again, please specify your full name when asking. And we'll also be posting a feedback survey that we encourage to be completed here shortly. And so look into next week. As you can see on the screen here, is just a preview for next week's presentation a week from today, Thursday, August 25th at noon Eastern. Galina Chirovkova, research scientist from CIRA, will discuss the CIRA proxy visible satellite imagery. And if you happen to have any questions about the Satellite Book Club or for configuration of satellite products, you can contact the Towers S team. That's Lee Byerly and Kashad Bowman. And we'll go ahead and start looking at some questions that were posted in the chat. We can start from the top, I suppose. So Dan Lindsay asked, are the surface winds on SBC Mesoanalysis page straight from the RAP model, or are they from a model-independent analysis of surface station data? He mentioned that he was thinking he remembered it being the latter, but could very well be wrong. I'm not sure if anyone on the line or if you, Brian, knows the answer to this.
Greg Grossens has mentioned that, and I'll quote it from chat, my colleague Andy Dean from SBC responded with the following: the mesoanalyst does an analysis of the observed surface winds, but it uses the RAP analysis forecast as the first guess. So both of the observed surface winds and the RAP will influence the SBC mesoanalysis output. It's not a model independent analysis, but it is not straight from the model either.
All right. Thank you, Brian, and thank you, Gregory, for bringing that answer. Bill Soderberg asks, did you happen to have a chance to look at the JPSS NewCaps soundings during this event?
The timing was a little off on the pass, so we couldn't really get a good view of the pre-convective environment. But yes, I did look at them and evaluated them in the context of the mesoanalyst role, and they're useful. Don't get me wrong; they're very useful. It's just that the past was a little earlier in the day than we could have used.
Yeah, it'd be interesting to think about what it would be like to have these polar orbiting, sun-synchronous polar orbiting satellites, maybe not to pass through midday, so to speak, or kind of within that time frame, but more so when if your golden hour, like you had mentioned, kind of towards that 0Z time frame. It would be interesting if how much of a difference or how much of an impact, if there's any impacts that might happen.
Absolutely.
Scott Lindstrom had a question and wondered if you ever used the GOES 17 in the office to get a better above anvil under anvil look at storms. I believe he's maybe referring to the more oblique view to kind of get an idea as to what the.
Yes, we do look at GOES 17. We're fortunate in Midland in that we can look at both GOES 17 and GOES 16. I admit that I was relying on GOES 16 more than GOES 17 on this day. Couldn't tell you why. I think just maybe out of habit, but certainly in a next event, I will look at GOES 17 data closer to see if I can get that more oblique look at the storm itself. Good question.
All right, thank you. And Bill, to answer your question on pictures of damage, I believe there were some at the very beginning of the presentation.
Right, I think it was slide 2 or slide 3. Slide 3.
Okay, thank you for sharing that. Jumping down a little bit, Mike Jamilkowski had a question and wondered if your presentation showed some overshooting tops, and if so, do these correlate with severe events on the ground? And I believe it did. I forget
Yeah,
what
you
slide
can
that
go
was on.
to if you go to slide 11. There's the what I call the fist of God, which is the penetrating top extending well into the stratosphere over Hermleigh, Texas, with the white circle. In the oval, cyan oval, you can see an above anvil cirrus plume evident in the storm. It's more apparent in loops than it is in a static image, but it is certainly there. And you can also see the Pecos County ice machine there near Fort Stockton, which also produced tornadoes over mainly open rangeland. Didn't hit anything, so we have no ratings for it. But the cold cloud tops, I measured minus 78 degrees C cloud tops at this time, so that was just about pegging the temperatures that I could get. Very high, very tall cloud.
All right, thank you for revisiting that. Steve Corfidi had a couple of comments. He said, nice presentation and good use of mesoscale data. I looked at the low-level streamline/convergence analysis on SBC Mesoanalysis page under Lake Effect 2. Those fields often can be used to confirm the presence of subtle boundaries detected via satellite and/or thermodynamic data. The subtle boundary in this case appears as early as 21Z in the streamline convergence analysis.
Absolutely.
Thank you for that comment, Steve. And just going down the line, another comment from Joseph Patton, mentioning to Stephen Bryan that this is a tall semi-isolated storm where the viewing angle of GOES 16 from the southeast would not be obstructed by nearby storm anvils. In addition, PWatt values that day were only to the value of 1.1 to 1.2 inches, meaning that there were not as many hydrometeors as there may be with PWatts closer to 1.5 inches.
That's true. The storms did trend more toward the LP side of the supercell spectrum, so that may have something to do with the ability of the GLM sensors to pick up FED and MFA as well as they did. Good comment.
Yeah, thank you, Joseph. And a final comment from Steve Goodman says, thanks, Joey. The forecasters should consider the GOES GLM line of sight in their situational awareness. A comment on that, at least I know locally here, since in our higher latitudes and almost kind of towards the edge of the field of the GLM scope, you know, we try to take that into consideration as well, and maybe kind of notice that the GLM might not pick up as much activity as, say, to our neighbors closer in the south and under closer to nadir of GLM. So it's something that we also kind of try to take into consideration, just the ever-present viewing angle in addition to the thermodynamic setup. But yeah, it's interesting with the advent of GLM, all these little nuances that we're trying to figure out and take into our consideration for our operational duties.
Yeah, as an aside, we use GLM data to help us issue airport weather warnings.
Oh.
So we have a requirement to issue an airport weather warning when there's electrical activity within 10 miles of the field, and GLM data is a big help because oftentimes you want to give that lead time before CG hits. So it's very useful product for airport weather warnings.
Very good. Joseph also says, love to see the GLM use in aviation. May talk to you more about that later.
I'm here.
And we have just a few more minutes before we'll go ahead and conclude this this book club. But I had a question for you, Brian.
Okay.
You know, you were talking about, you know, or at least there was an underlining theme, it seemed, just the importance of boundary identification. And in particular, not, you know, for tornadogenesis. And I was wondering if you've noticed any evidence of using satellite imagery to infer this this deformation that might be happening within a boundary. I know there's been proven points that it can help in just boundary identification in general, but in your particular instance, and maybe not in this case because there's a lot of cloud debris, but you know, maybe in past.
Yeah, there was a lot of high thin cirrus clouds that were evident in satellite imagery at 21Z up through about 0Z that kind of obscured boundaries somewhat. But I inferred the billow clouds versus the HCRs versus the open cell cumulus clouds to infer where the approximate location of boundaries were. But it was hard to detect because of the high thin cirrus that was obscuring a lot of the surface features initially.
Yeah, that's also a really great point to bring up. You know, inferring boundaries just through the look and the texture of cumulus clouds while you can see them. Is there how is there a way that you were able to communicate these boundary locations to your other forecasters? Were you kind of doing like a hand analysis or just verbally talking about where they are?
Yes. Okay. Yes to both. It was doing hand analysis, and I cannot stress enough the importance of doing hand analysis in concert with satellite data. It's very, very important, and it helps you pick out those subtle features and those boundaries. But I was communicating with our radar operators and with the event coordinator on locations and expected storm modes and what the storms might do.
And I'm going to go ahead and throw a plug in for the PGen tool within AWIPS that could really help kind of illustrate the thoughts of a mesoanalysis, which, you know, not only just you can overlay it on satellite, but you can overlay it on all of your planes within your D2D cave instance.
Right.
It's been useful. All right. Well, we'll have if you happen to have any further questions, feel free to email them to Kashad Bowman and or Lee Byerly, and as well as Brian Curran. We really appreciate you doing this, and yeah, we'll hand it back over to Jordan for final comments. Oh, go ahead if you had any more.
Thanks for having me. I appreciate it.
All right. Well, thank you so much, Brian. That was a great presentation. And Carl and our audience, thanks for all the questions and the dialogue. I thought that was very good and very good use of our book club time today. A week from today, the book club continues, Thursday, August 25th at 12 noon Eastern Time. Galina Sharakova, research scientist from CIRA, is going to discuss the CIRA proxy visible satellite imagery. So if that's something that interests you, please join us again next week. And in the meantime, if you have any questions about the configuration of satellite products or the Satellite Book Club, Lee Byerly, Kashad Bowman can help with any of that. So if you haven't heard, as part of the NOAA Leadership Seminar, Ken Graham is going to be speaking at 4 p.m. Eastern Time. So if you're interested in that, feel free to check that out. Otherwise, hope everybody that's heading to National Weather Association annual meeting next week has safe travels. I will see some of you there. And if not, I hope you'll be able to join us next Thursday or whenever the next book club comes around that fits your schedule. Have a good end of your summer, everybody. Take care. Thank you so much.
Y'all be